Alright guys, welcome back to the first Math Notes video of Chapter 10. This is 10.1.1. We're going to talk about permutations and combinations. These are ways of describing how various arrangements of items can be counted. Before we really delve into these math notes, I'm going to do a little sidebar. The first example discusses ways that we can find the top 3 winners of a race of 8 people. Before we do that, I want to think about all the different ways we could just arrange those 8 people. So if we think about there being 8 people in the race and 8 positions that they could finish in, they could either finish in first, second, third, fourth, fifth, sixth, seventh, or eighth. Fifth, sixth, seventh, or eighth. Let's think about how we could fill those slots in with our runners. So if we have 8 runners and we assume that it's all random, we have 8 people that could come in first. Well, once we figured out who comes in first, now there's 7 people that have the option of being second. After that, there's 6 people that are available to be third. That leaves us with 5 people that might fill in the 4th slot, 4 people that might fill in the 5th slot, 3 people that might fill in the next slot, 2 people, and then at the very end there's only 1 guy at the end, so that's just 1. So to find all the different possibilities, we multiply these numbers. And when we multiply a series of numbers like that, that's decreasing by 1, we call that a factorial. So this is 8 factorial. Or if you want to be fun about it, you can just call it 8. It's got the exclamation point, you see. So 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And if we wanted to know all the different ways that you could arrange those 8 people in a particular order, that's what our answer would be. And there is a button on your calculator for this. If you're using the TI, it's under the Math menu, but you can find it on most calculators. Incidentally, that works out to be 40,320. So if you were placing bets on the exact order of the winners would come in, and you didn't know anything about who was better than anyone else, and you were just doing it at random, then you would basically have a 1 in 40,000 chance of getting it correct. So there's lots of different ways to arrange those 8 items. So I just wanted to start with that before we got into the rest of the math notes. Let's look at the next part here. So permutations and combinations describe how various arrangements of items can be counted. For example, if 8 people are running in a race, how many different ways can they come in, first, second, or third? Well, I've hinted at that with the way I've drawn that, except for first, second, and third, we would only have 3 slots to fill in, first, second, third. So we would have our 8 people, our 7 people, and our 6 people, and if we multiplied those together, we would come up with 336 different possibilities. This is a problem called a permutation, or arrangement of items in which order matters and items can't be repeated. So permutations, order matters, and items can't be repeated. The notation that we have for that is NPR, where N are the number of items, number of items or people or whatever available, and R are the number of slots that you have to fill. And I'm using that term kind of loosely there. And it turns out the equation for that is N factorial over N minus R factorial. Well, if we look back to the example that I just did, we figured out that we could arrange 8 runners by doing 8 times 7 times 5 times 4 times 3 times 2 times 1, which we have down here. But we only have 3 slots to fill here, which is our first, second, and third. And if we want to write that as an equation, we can put 5, 4, 3, 2, 1 underneath, because then we'll end up with just a bunch of big ones. Those 2 5s will cancel, those 2 4s will cancel, those 3s, those 2s, those 1s will cancel. And we'll be left with just the 8 times 7 times 6 that we had up here. So the formula for permutation is n factorial over n minus r factorial. Let's look at another example. 8 people are eligible to receive $500 scholarships, but only 3 people will be selected. How many different ways are there to select 3 people? So in this situation, it doesn't matter what order you're selected in. Everybody receives a $500 scholarship. So that's actually going to eliminate a lot of options, because if we think about there being 3 people, and let's say we gave these people names, really clever names like A, B, and C. On a permutation where order mattered, A, B, C would be different from B, A, C. And it would be different from ACB. And it would be different from CAB. And it would be different from the other arrangements that were possible. I went ahead and paused it and rewrote it because I wasn't being too systematic the first time. So there are 6 possibilities there for arranging those 3 people. And but they would all be the same as one possibility under a combination, because those would just be the 3 scholarship winners. So if we were talking about permutation, these would be 6 different groups. But for combinations, this is all just going to be one group. So what happens with a combination where order doesn't matter, and again, items still can't be repeated, is that we have to divide by all the different ways to arrange those positions. So here we have order doesn't matter. So if we take, we write this as 8C3, and we'll use the word choose for combination. I'm not sure if I set it up there or not, but for permutations, mathematicians use the word pick. In combinations, we use choose, so that you know when you're talking to someone whether or not it's a combination or a permutation. C goes with the C, P goes with the P. So to compute the number of combinations, first calculate the number of permutations and divide by the number of ways to arrange each permutation. So we had 8P3 before, which we had already figured out was 336. And if we take the 336 and we divide it by these different arrangements right here, which is 3 factorial, or 6, then you should get 56. So we build that into our equation by adding this term to a combination. The r factorial down there at the bottom. So let me zoom in on that equation. So our NCR is equal to n factorial over n minus r factorial. This is the permutation equation. And then we come in and we add an r factorial to the denominator to give us NCR. All right, guys, there you go.